Black holes. The heavenly killer whales. Even light cannot escape the wrath of these objects because of their immense size. These are everywhere in the universe, moving around and consuming anything that gets in their way. The most terrifying aspect is that, according to scientists, the Milky Way alone contains between 10 million and a billion such black holes. The closest black hole to the Earth is Gaia BH1, which is 15,060 light-years distant. Therefore, our planet is quite safe. In contrast to supermassive black holes, which have billions of times the mass of our Sun, such black holes are extremely small and very difficult to detect. As they awaken, these enormous beings eat everything in their way. And after an extensive nap, one such creature has now awoken.
You are watching Call of the Cosmos.
A supermassive black hole in the outer limits of the observable universe has just been seen by astronomers to suddenly become active. This black hole, which formed 10 billion years ago, emits a brilliant light demonstrating that it started consuming a lot of matter very quickly. This incident is regarded by scientists as one of the most extraordinary manifestations of such activity ever seen. And it's been referred to as J22 1951. Astrophysicists claim that in recent years, our comprehension of the capabilities of supermassive black holes has considerably increased. Stars being torn apart and the existence of accreting black holes with very fluctuating luminosities are notable discoveries. And despite all the knowledge we have amassed over the years about black holes, J22 1951 stands out as a particularly good example of a black hole that caught us off guard. Every galaxy has a massive black hole in its center, although they are not always active. Some, like Sagittarius say in the Milky Way, remain heavily dormant because there isn't much nearby material available for rapid consumption. But across cosmic timescales, the activity of supermassive black holes changes, frequently switching between active and dormant states as material becomes available. J22 1951's signal has a distinctive duration despite having a comparable color. Killer novae generally disappear after a few days, but J22 1951 lasted substantially longer. And that's not the end of it. Further research showed that the light released from the black hole had traveled across a distance of 10 billion years rather than 500 million, which was considerably farther than initially assumed. At that precise point in space and time, the flare came from the galaxy's center. As a consequence, the observed brightness was incredibly strong, suggesting that there was more than one explosion going on when the material fell into the supermassive black hole. Rather, it was a continuous glow produced by the material spinning about the harsh environment. The flare's suddenness and intensity clearly imply that the black hole quickly started eating large amounts of material, changing from a dormant to an active state. There are two reasons why this phenomena might exist. According to the first theory, the black hole's feeding frenzy was started by material from a disk that was circling it and had finally gotten close enough for the black hole to eat it. The black hole would then become a functioning galactic nucleus as a result. A star that got too close to the black hole and was destroyed and then accreted, a process called as a tidal disruption event, is the subject of the second theory, which is more violent. More observations will be made to establish whether the theory is more credible. Meanwhile, the James Webb Space Telescope has discovered the oldest black hole ever detected in the universe. Observations collected through the James Webb Space Telescope have revealed an active supermassive black hole 10 million times the mass of the Sun, one that is actively growing as it slurps up matter from the space around it. At just 570 million years after the Big Bang, this is the earliest growing supermassive black hole detected yet, although scientists are hoping it won't remain the record holder for long. The black hole was found inside one of the earliest galaxies ever detected, previously known as EGS Y8P7, though since renamed Sears 1019. Its discovery could help with one of the biggest head-scratchers of the early universe: how the black holes in the cosmic dawn grew to such large sizes in such a short amount of time. We found the most distant active galactic nucleus and the most distant, earliest black hole we've ever found, said an astrophysicist associated with the finding. Scientists were initially looking at Sears 1019 as part of their work investigating light produced by star formation in the very early universe. This light, called Lyman alpha emission, is thought to be generated by the ionization of neutral hydrogen by star formation activity. The early universe was filled with a fog of neutral hydrogen, which prevented light from propagating. It was only after this hydrogen was ionized that light could stream freely. This epoch of reionization, as it is known, is not fully understood. We know it took place in the first billion years after the Big Bang, 13.8 billion years ago, but seeing that far into the early universe is really hard. Sears 1019 and a handful of other super-early galaxies are excellent targets for this research, because they're relatively bright. The galaxy was identified in Hubble data in 2015, and at the time, was the earliest, most distant galaxy observed. Subsequent observations confirmed its existence, but more detailed information remained elusive. The earliest light in the universe has shifted so far into the infrared part of the spectrum, due to the universe's expansion, that a powerful, dedicated infrared instrument like JWST is necessary to probe them. So, when JWST came along, Sears 1019, the brightest of the Hubble galaxies from this epoch, was an obvious target. The telescope stared at the galaxy for just 1 hour, with all 4 of its instruments, but returned with a wealth of data. In the moment I was kind of like, wow, look at everything we can see with JWST. We've seen this whole portion of the spectrum of this galaxy, and any galaxies early on in the universe, we've never seen before, said astrophysicist Rebecca Lawson. I was just overwhelmed by the amount of information. But then she noticed something she wasn't quite expecting. In addition to the light of star formation, there was a broad emission feature usually associated with AGN. And when she mentioned it to some AGN researchers, things started to get interesting. Typically, a galaxy in the early universe emits either light from an AGN or light from star formation. To see both in the same galaxy was extremely unexpected. There is some impact that the black hole is having on the emission lines that we are seeing, but most of the light we see in our images is still dominated by the star-forming part of the galaxy. That a supermassive black hole existed more than 13.2 billion years ago, and was seen growing, is not as surprising as you might think. Much larger black holes have been detected in the early universe. Scientists still do not know how the black holes in those galaxies got to be so massive, that early on in the universe. But with the technological prowess of Webb, we will soon find out. What do you guys think? Drop in your comments below, and don't forget to subscribe to Call of the Cosmos. Thanks for watching. We shall see you again very soon.
You are watching Call of the Cosmos.